Welcome back to another episode of Make Me Data Literate. This is a very exciting one for me and a very special one because of my longtime friend, Associate Professor Karen Lamb, who is also a director on the board of the Australian Data Science Education Institute, is here with us today. Welcome, Karen.
Thanks for having me, Linda. Sorry it's taken so long.
I finally pinned you down. We're good. So, can you tell me who are you and what do you do?
So my name is Karen Lamb, as you said. I am a biostatistician and I co-head the biostats node for the methods and implementation support for clinical and health research at the University of Melbourne. So I'll call it MISH for short, but MISH essentially is an idea of a kind of one-stop shop for your methodological support for high quality health research. So we've got people in co-design, we have people in health informatics, data informatics, myself obviously biostatistics. We help with design and conduct of health studies, trials, observational studies. And we also have people from the end of looking at the health economics perspective, so seeing if you found something to be efficacious, is it actually going to be possible to move forward with it because of the costs involved. So yeah, I've been here for about 7 years now, and we provide support to numerous health researchers and clinicians across the University of Melbourne and the affiliated hospital partners.
So that's what MISH does. What is a biostatistician?
Oh, yeah. Biostatistician is someone that is from a statistical background. That's really great start, using the name of the profession to help. But essentially, a role of a statistician is someone that will help, I think, ensure robust study design and data capture and analysis. And particularly as a biostatistician, it's my role to help particularly with health research, clinical research. So lots of work with human populations. I originally came from a background of studying more what we call a cohort study, so looking at observational research to see different things that could cause different health outcomes, diseases, and so on. So you take data from a sample in the population, follow them over time to see what could potentially cause different health outcomes. But more recently, I guess the primary piece of work that I do as a biostatistician here is working in randomized controlled trials, where we will help health researchers, clinicians, when they've got a particular intervention in mind that they want to study, and we help them to design something to try and estimate whether that intervention is worthwhile using and actually, as I say, has a desired health effect.
So an intervention might be something like a drug or a lifestyle change, things like that.
Yeah, so typically for us, it's less often drug interventions. That's typically more, I guess, the pharmaceutical sector than what I do. A lot of the work I do is more behavioural interventions or exercise interventions. I guess I work a lot with physiotherapy group, in particular at University of Melbourne, that do a lot of work in osteoarthritis. And so a lot of their interventions they're interested in are exercise interventions. And so or even educational interventions to sort of, people often think a good response to some of these challenges is to go and have surgery. And it's to try and actually say there are alternatives there, and to try and promote things like exercise that we know could have multiple benefits. So it's more around that than drugs as such, although sometimes that is a component of the kind of work we do.
I love that. So basically your work is to ensure that the studies that happen are as rigorous as possible, that the evidence is as strong as possible, that the outcomes are as clear as they can be and not muddied by problems with the design of the study and things like that.
Absolutely, because I think I used to say to people that I would think of statistics as the science of disappointment, because early in my career, and actually still now, but you often would get researchers coming to you at the end. So people think of statisticians as being the people that you go to when you've got your data, and we work our magic with it and analyze it and get you the result that you were looking for. But there's so much more to the job, which is why I love the job, because that's such a tiny piece of actually what the role of a statistician is. My job largely involves talking to people, particularly where I am now, sort of heading a group. I do still occasionally do some of the analysis, but largely I talk to researchers to try and help them frame their questions in a manner that can be answered. And then taking that well-framed, refined research question, thinking about what's the appropriate design to enable them to answer that question, then taking that design into a well-developed protocol where, again, people would have the perception that statisticians may only do your sample size calculation, how many people do you need for this study, and then write your couple of sentences, the stats method. But actually the role is ensuring consistency and rigour throughout the whole proposal. So I would never get a protocol and just do the stats sections, because to me the whole thing is statistics. If it doesn't work from the start, if the design isn't right, then there's no point in me having a nice, beautiful sample size calculation. So it's really about the rigour, robustness of the science from the outset, and then continuing with that. I then don't leave them alone. I want to look at your questionnaire. How are you capturing the data you need? Is the tool you're using to capture your measures, whether they're outcomes, exposures, patient characteristics, are they validated, reliable measures? Have we thought out potential problems with the responses you have there? Are we capturing all the variables that are of key interest to you? We're not just focusing on outcomes here, but there are other things in the process of your trial that might be important, or your observational study that you need to make sure you've got. Then looking at, you've designed the survey, does the database align with your survey? So some people might just design the survey straight away in an electronic database that means it's all in one step, but sometimes people like to work in Word or whatever, create their survey, and then I check to see, is the database robust to actually get that information, and can we have some efficiencies there? Now, I never design a database, that's not my role, that is more your data managers, health informatics people. My role is just to test it to make sure that the data that we get out is actually going to be useful. I can't tell you the amount of times I've helped with a survey but then looked at the database, and what I'd hoped were these nice, clear drop-down menu responses or whatever. I'm not saying I'm all for qualitative data as well, by the way. I'm gung-ho for mixed methods and having qualitative information. But largely what we're needing in these studies, if you've got me, is quantitative data. And so if you have all these people writing potential free text fields that I then would have to try and code up, then, or, well, I wouldn't, I would go back to your data manager. But essentially that's why we need the front end all sorted before we even get to the point of analysis, reporting, all the rest of it.
So you must have the same occupational hazard that I do, which is seeing studies reported in the news and just tearing your hair out at the both the reporting and often the study design. You're just going, oh no, it doesn't show that. What are you doing?
Yeah, I feel like, you do this qualification or you work in this field and you're just an eternal skeptic. So it is a lot of, as you probably say, like, show me the data, but beyond that, show me where the data came from. Tell me how you got to this. Tell me, how you cleaned your data or what subset of the data you took to try and get this message. There's so many different ways to get the answer out. And so what I work very hard to do with anyone I'm working with is have a clear plan for what you want to do. And even if you come to me when your data's collected, I still want to work with you to have a clearly defined statistical analysis plan that outlines what we're trying to do, what the limitations are of the data that we've got, what all the steps are we're going to take in place for the cleanings, just so that everything is transparent, because there's no correct model per se. Everything is based on assumptions, but let's be transparent about the assumptions we're making and justify them as much as we can. and be mindful that our assumptions someone might disagree with, but at least they'll know what assumptions we've made and why we made them.
I think I can stop teaching workshops and just play an hour of Karen saying that.
Me on my soapbox.
It's perfect. I love it. Um, what did you have to learn to do your work? Was there anything missing from your formal education?
Um, Chat, really. I've talked to you about this before, Linda, I'm sure, but it's really interesting recently reflecting on it because I think had you asked me this, and you probably did years ago when we first met, the thing that I really wished I'd done more of or felt was a real weakness in my background was the computing elements. So I'm statistics trained. Like rarely people wake up and go, I want to be a statistician when I'm older, but and I certainly didn't do that. Um, I'm fortunate that my dad's a mathematician, happens to be a pure mathematician, so gung ho for the beauty of maths, less excited, although actually no, he's excited about everything, but more me. I'm on the other end of the spectrum where I'm like the utility of it. How can it
Yeah.
help people?
What is
So
this
it
good
was
for?
all well, it was always the maths element that brought me into this, not the computing. And I think it was a real shock to me. So I started doing mathematics at university and took statistics because it was like maths. That was it. That was basically it. Like, this sounds like maths, let's do it.
Hmm.
Um, but I really took to statistics because when I was studying at the University of Glasgow, they had separate statistics and maths departments. And the statistics department, not only were they much more on the first name term basis, John, this, Tom, Jim, whatever, bearing in mind, yes, largely male names here, but I just really liked that vibe compared to going upstairs to the maths department and it was Professor so and so. So, of course, that was one element for me because I'm not really a huge fan of hierarchies. But I think the other thing was they really taught you with examples of what they were doing. So they were doing cool methodological stuff, but why? Who are you working with and why are you doing it? But as I say, it was a real shock to me going into that because computing was never something I was particularly interested in. I'm of the generation where we did have a computer at home when I was a teenager, but I was very resistant even to writing essays or anything on it. Like I am still very much a handwriting person. If I handwrite it, I know it. If I typed it somewhere, it may not exist anymore. So then I went maths again, still very chalk and talk. Go to statistics and suddenly start with we were using something called Minitab,
Oh,
and it's a
that takes
it's
me
a
back.
reasonably user friendly start off stats program where it does have the drop down menus and things. But I started learning with drop down menus, and then we suddenly were moving into more statistical computing and doing things in S plus, which was subsequently R. Um, and I just really struggled. I mean, I remember in my honours doing statistical computing and the sheer frustration that my professor had because he's like, I was getting A's in stats computing, but nothing I did ever worked. It's the joy of like, show me you're working. And he's like, Karen, you're so close. I'm like, and yet so far. Because I hated that it had to be just perfect or it didn't work. And I just couldn't be that perfect. And for the longest time, I have carried that with me as like one of my things with stats that I really struggle with, except forgetting that the fact that the personality I have, I like to jump into whatever language anyone's using and see if I can work. I like looking at other people's code. I like pulling it apart. I like understanding what's going on. I just don't like really doing it myself. So that was a long way of saying, had you asked me, even maybe a couple of years ago, I would have said, this is what was missing. This
Mm.
is all what was missing from my background, even having studied statistics and then going on to a PhD in mathematics and statistics. But more recently, I think really has been the human element of being a statistician, which is just not emphasized at all. And yet, you know, the discipline that we're in, it's rare to have you just sitting by yourself in an office. I know there are some very, very methodological statisticians that
Mm.
are probably sitting doing formulaic stuff, I don't know, probably doing the blackboard, whiteboard stuff. This shows you the way I'm chatting, how far removed I am from this. But my job really is to bring bring people along with me, bring the clinicians, the health researchers, get them invested in working with me and other statisticians, knowing that we're not here to hinder their progress, we're not here to cause them any problems or to essentially give them answers they don't want. We want them to work with us to make this the best it possibly can be. And that all comes from having good communication, a clear appreciation of maths anxiety. I have met in my career collaborating with people, applied folk come in, professors in tears because the thought of coming to speak to a statistician was too much because of their feelings from high school. And I mean, hell, I don't think I'm a particularly scary person, but that name, that profession was what was carrying all the weight there. So I just wished, and still wish, there's more emphasis on that side of things and the people management, probably the project management, but also helping me to get it right, helping me to, I would go into meetings when I was brand new in this job and think I had to show off, think I'd have to impress the collaborator with what I knew in statistics. When actually that's just terrifying for anyone and doesn't help anyone. When really the role, as I say, is bringing them along with me, learning what it is they need and making sure I've got that all captured well so that I can work out what I have to do next.
My catch cry is tech is easy, people are hard. And it's interesting, I get these themes that come up through no planning of my own, but the last episode of this podcast that I recorded, which I'm editing just now, the my guest, Professor Crystal, she said that what was missing was the human element. She wasn't taught enough about people. Specifically, she said, I wasn't taught how to be a good human. Yeah. And, the connection is there. That is part of, being a good human is not coming in and, smashing your expertise out on the table. Being a good human is coming in and listening and connecting and reaching people where they are. And, same with being a good teacher.
Also, reflection, there's a couple of things I've been thinking about recently, and some of it is the ability to realize that other people's behavior is not necessarily on you. I refer back to, the science disappointment and so on, but ultimately at heart I'm a people pleaser. I can't help it. I want people to have a nice time, but that's in stark contrast to what I'm often doing in my job, where I'm like, I'm really sorry, you just can't do that. And I think it's taken a lot for me to, one is to reflect and say, yes, you can't do this. I know you really wanted to do this. Here's what we can do. Here's what we can learn from this. And here's how we can do it better next time. And take that to the people I'm working with. And the other thing for me is not to internalize it, that if a collaborator is really disappointed or frustrated with how things are working, that it's not my fault necessarily. And I think that's something I wish, it's that bit of resilience that no one sets you up for. I mean, you do a maths degree, a stats degree, and it's like, yeah, get the data, get your computer out, do the maths. And it's like, that is so little of my job these days that, I mean, it really shocks me. I'm very happy that is less of my job as I progress, because I really enjoy working with other people and learning what they want to do. But sometimes as a statistician, the frustration is taken out on you. It's hard.
Yeah, that's brutal. And I have to take the opportunity now to brag on your behalf, because I know that you won't, but that you are, for the second time now, nominated for a Eureka Prize for outstanding mentoring of researchers, and absolutely deserved. Like, your mentoring programs and the structures you've developed at your work to teach people these skills that you feel were missing, it's just glorious. I love it. I will stop embarrassing you now. Is there one thing that you wish everyone knew about data? Is there something that would make your life a lot easier, or just make everything better if everybody understood this one thing?
I always find it really interesting when I have to think about data like in its own right without, as I say, all the precursor and the design. So I guess maybe that's what it is. It's the being mindful that the data that you're looking at was collected for a particular purpose. And even if it was collected for a particular purpose, it doesn't mean it was collected well for that purpose or represents the people it truly should. So I think, as a statistician, and particularly in the fun AI world in which we find ourselves, I'm constantly thinking about the potential for bias and the potential of misrepresentation. And also, to be honest, even more now, thinking about the importance. I've kind of always thought about this in the background, but your data provenance. Like, as I say, talking a little bit about, why was your data collected, but really being able to trace that back carefully. Interestingly, this year with some of the statistical groups that I've visited, there have been some people doing reviews on existing prediction models that are out there, and they maybe started off the review with one purpose, but actually in going through this review, they discovered that some of the big data sets that were being made available out there that people were using to develop a prediction model quite innocently. I don't think there was any, well, I don't believe there was anything malicious there, but you couldn't trace back the provenance of the data. So was this real data? Was this fictitious data? But if data sets exist and you don't know, why, then that's a problem. And then actually this PhD student that was working on this piece, who I probably should put you in touch with, Linda, I think you'd have a good chat with them. But actually, in exploring the data a bit more themselves, we're finding weird things in the distributions, things that wouldn't make sense if these data truly were data for real people. So yeah, be worried if you don't know much about the data, and then be worried if things appear too good to be true, because they likely are. And also just look at your data, describe your data. Does it make sense? Does it actually look like you expect it to? Are the values representative of what a real distribution would be? And if you can't answer those questions, don't be using the data.
I like that. I like that a lot. And it's a theme that keeps coming up, is that idea of, where did your data come from? And the idea that data is a human artifact. We forget that. We think of it as some kind of, mathematical truth. This is the number of people who were in this room at this time, and that's a thing. It's like, well, hang on. Even that is complicated. Are we counting people who stepped out and came back? Are we counting, was it the number of people who were in there for the entire session? Was it at what point? It's like, what counts as streaming a song on a streaming platform? Is it the whole song? Is it all but the last 10 seconds of the song? Is it 30 seconds? Is it a minute? How do we count these things? And every bit of data has a definition behind it that is a human artifact.
Exactly. And it's like, are we asking the correct research questions or the correct questions throughout? Because another thing you sometimes see, if you're thinking in a clinical sense, measuring something objectively, like your blood pressure or heart rate or something like that, and even with these more objective measures, we're aware there are some challenges. Like, I'm terrible with jargon, so I can never remember the exact term, but when people say your blood pressure will spike when you're actually visiting the doctor because of that doctor effect.
White coat hypertension.
Thank you, that's what I was looking for. And so is that actually measuring, and is that accurately measuring what you need when it is in theory objective? But I probably come at it more from, I guess, the subjective questionnaire measures we have, or the tools. I've worked a lot with psychology researchers, behavioral scientists, people that are interested in things that are quite hard to define. around well-being or mental health, quality of life, that kind of thing. And it's interesting as well. Sometimes the perhaps lack of consideration, particularly I guess when people are earlier in their career in research and maybe just less aware of these things, about the importance to look and see if there is a tool or a measure that's validated and reliable for the people you want to study. And if you
Mm.
have created your own tool to measure something or your own question, should you have? Can't you go and see if there's something else out there that would be a better measure? And actually, like, to be honest, every question in a survey you have to kind of look at with that mindset. Any question in a database, was that question asked in an appropriate way? And if not, well, again, should we be using maybe the other elements of the survey that are good, but maybe that question is just not a good one to use.
My favorite example of problematic survey questions is the classic workshop evaluation question, which can be anything from "How wonderful was this workshop today?"
Oh
to
my word, yeah,
"How did you
leading
find this
questions.
workshop today?" 1 to 5, like a completely different outcome, which requires an understanding of human psychology and behavioral psychology
Mm-hmm.
that most people who are writing surveys don't have, which is why you need,
Absolutely.
the involvement of someone who does this for a living and who has that expertise. But crafting a survey is simple, right? There's what could go wrong.
And it's even that thing of like talking through people not making every question compulsory as well. So, now if
Mm.
you're using certain databases, you can just say forced response for everything or you can't progress. And you would think that me as a statistician would be gung ho for that. I don't want missing data, but I am prepared to give up on some data to prioritize other parts. So
Mm.
there are certain things. Take income, for example. I've worked a lot in social epidemiology, and often they're trying to capture different aspects of what they would class as socioeconomic status, whatever, again, this broad construct is. But looking at employment, looking at education, and then there's usually an element of reporting your income. But people don't necessarily want to tell you their income. They might be quite prepared to tell you their educational background,
Mm.
but not their income. So, do I want people to be forced to respond to a question about their income when it's a desirable rather than an essential for this particular survey?
Yeah, and does that mean you'll have people bail from the study who would have filled it out otherwise? And are you therefore getting a sample size of only people who are prepared to tell you your income? And is that a skewed sample? So many questions.
And then the other fun thing with asking income is the option as well of if they do a forced response, they might have a don't know or prefer not to say. So that's
Mm.
one way of capturing the data. But essentially, for me, what do those categories represent? I still don't know.
Mm.
If you're trying to capture like this ordinal measure, if you like, of income, what do I do with them? To me, they're
Yep.
still kind of missing. And
Yep.
then people do all kind of weird and wonderful things with it. So yeah, it's tricky. Survey design, absolutely. I wouldn't say I'm an expert at it, but I definitely know big no nos. So
Yeah. Yeah, it's an interesting one. There's so many ways it can go wrong. Um, which leads us to mistakes. What are the worst data mistakes you've seen?
oh wow. Where do I start? Um,
So many.
oh, look, I feel like I could start with the kind of common general ones without making it seem like I'm naming any names in particular. But I think, the common thing we often complain about as statisticians is the statistical significance over clinical or meaningful difference. And this comes up all the time. And even though we've been discussing it for as long as, well, longer than I've been doing stats, but it's this idea of your p value, your significance level of your test being the be all and end all of your research finding. And if you fail to conclude that something is significant, then that's it. Your world is over, or you can't get this output out there, or there's no point in exploring this any further. And it's just so incredibly frustrating that just the research environment we've been working in for so long has really pushed for this statistical testing, significance testing, and then that is the emphasis in reporting, rather than, say, the average difference in blood pressure between your two groups, which was the measure you were interested in. You're still going to estimate that. Maybe you found that it's not significantly, from the statistical perspective, different between the groups, but what difference did you detect? What is the confidence interval that can tell you what that difference may be in the population? And while no difference is plausible, it's not the only potential difference in the population. And I think this misrepresentation of findings using significance is probably the one I encounter the most. It's probably not my best example. I have some absolute howlers out there, but this is the one that I probably still have to talk the most about in my meetings with researchers.
I guess it comes back to the point of it all. Like, why are we doing the stats? Why are we doing this study? What do we actually care about? And in fact, p-value is not the thing that comes to mind. It's like, is this intervention worth it? P-value doesn't necessarily give you that.
Yeah, I reviewed an article recently, and without saying anything about it at all, basically in my first reviewer response as a statistical reviewer said, what's all the statistical testing about? I actually think this is an interesting article, but really it should be descriptive. Just tell me what you saw. I don't see a need for all of these p-values. And their response to me was that they were trying to make inference to the broader population. And that's like, they were essentially trying to tell me what statistics was. And I was like, look, I don't disagree that that's why we will do like some of this statistical work, but all of your conclusions are based on p-values for the over 120 different models that you have fitted. At no point have you told me what parameter you are wanting to look at in the population, in
What?
which case you've decided that the p-value is that. So, oh, Linda, I thought I was going crazy because I was like, I'm sorry, what? So I then had to push back again, going, again, I don't think your piece of work is necessarily a bad piece of work. You've just focused on the wrong thing.
Yeah.
Like, I think you've done this potentially useful piece of work, but it's all been masked by this focus, unnecessary and incorrect focus on p-values.
That's disturbing. That's really disturbing.
Mm-hmm.
Have you ever seen data deliberately misused, and how do we spot it?
I guess deliberately misused. I think there's some interesting articles out there about, I think there was an American Stats Association survey of biostatisticians in the States around bad practice and bad requests from the early career, in particular, biostatisticians I think we're faced with, and they had some really nice examples around, changing your research question after seeing the result of your original research question, which is why I'm all for full transparency, because I think, I'm originally from more of an observational study perspective, and it's really tricky in an environment where there's a lot more expectation around your presentation of trials. So if you're conducting a randomized controlled trial, if you want this actually be considered as a good trial, it has to be registered. So in Australia, there's Australia New Zealand Clinical Trials Registry. So you have to register your trial, tell us who your eligible population is, tell us what your sample size you're aiming for, our primary outcome, that kind of thing, and brief details of your analysis approach. You have to have a detailed protocol. Of course, it will have gone through ethics. You likely will have published your protocol in a journal. And then when you're getting to the point of doing your analysis and reporting your findings, prior to that point, you should have developed a fully rigorous statistical analysis plan that ensures that what you had in the trial registration is consistent with your protocol, is consistent with your plan. Any changes since the registration or protocol are clear. Any major deviations are clear. And then you publish the trial result, irrespective of finding, ideally with the stats plan as a supplementary file that tells you the full detail of everything you planned and why. Now, observational studies, on the other hand, is a bit of a wild west. We just don't know how many analyses are out there where things just don't end up being presented. So we can push as statisticians, data scientists, for clearer rigor by, if you get asked to assist with a project, making it clear in your stats plan what your exposure was, what your outcome was, who was in your eligibility population. And again, if there are changes along the way, which there sometimes are in trials as well, have a record of all of that, have full transparency. But again, it comes back to this ignoring findings if they're not statistically significant. So I think that one is particularly frustrating. Another one is like, after the fact, dropping people from your population after you've maybe not found a statistically significant result. You'll go, oh, actually, I really meant to exclude these people. They're not relevant for these reasons. So
I'm just going to look at the people it worked on.
Exactly. So yeah, it's really tricky. Another thing too, again, coming back to your questions around the data, is just trying to use data for something that it just wasn't designed to do. And so why are we actually doing this? Like, I mean, a key example is this proliferation of these prediction models out there. And you know, people will often come with data sets and they want a new prediction model, and you're like, well, why? There's so many prediction models out there, and they're not used, they're not validated. Are they actually useful? This is research wastage. But it's this feeling that it's not going to be considered important if they haven't, in a small study which is exploratory and still novel in its own right, it's this feeling that descriptive might not be enough. And I think that's really sad when you can still gain a lot of information from descriptive without going to all the effort of producing a model that is completely unnecessary. So,
and not useful. What is the first question you ask when you look at graphs in the media?
Usually I groan when I see graphs in the media, but no, I will often...
Me too.
Oh, I'm obsessed with looking at, you know, axes and where the start point of your axis is. Like, are you misrepresenting the data because you've not started at 0, for example, if you've got a bar chart or whatever. The thing that I hate, people don't label their axes. This is not just in the media. People just don't label axes, and it's so frustrating because, like, this is supposed to help you understand the information without you reading. So if you don't label it, then, well, it's no use to me. I really, really hate pie charts. Don't get me started on how much I hate pie charts. And I think where I've seen them misused a lot in the media is, you know, where they actually, you know, should sum up to 100%, and they'll definitely exceed that. But just since you've given me the platform to get on my soapbox and raise my bugbears, I think
go for it.
The frustration is if something can be more easily understood when you're comparing relative heights. So a pie chart might be really useful if you've got a small number of categories, right? Even then, I still don't love them. They're just not. People don't understand differences in areas as easily as they will in height. I mean, just mathematically, it's more complex. So if you're wanting a simple descriptor to understand data, stop using pie charts, particularly when you've got so many categories, because I don't understand it, and I'm a statistician. So So I look for these laws, but the other thing for me, if I'm completely honest, and is over complex graphs that are completely impenetrable.
Yeah,
Like people have gone gung ho for complexity over conveying information, and
yeah.
that really frustrates me. As I say, I am a big advocate for simple clarity, and if a bar chart works, give me a bar chart.
When I first started teaching data science in high school, I was working with a maths teacher who kept saying, "Why are we teaching graphs? We already do graphs in maths. This is pointless. It's a waste of time. We're duplicating effort." But then she saw what I was doing, which was teaching graphs as communication instruments. So I wasn't teaching the
Mm.
technicalities of the graph. I wasn't teaching, the mathematics of the graph. I was teaching, what are you trying to say with this graph? What's the one thing you want people to take away? What's the best way to convey that? She was like, "This is a revelation. I'm going to use this in my teaching." It's like, why are we not doing this already? Like, how
I
can
know,
you
and
teach
it's
graphs without pointing out that they're for communication? It's their whole purpose.
exactly, and I think I've heard you say something along those lines before, and I found it so bizarre because actually, when I think of where I learned best use of graphs, it was from like physics and chemistry at high school. It
Mm,
wasn't maths. I actually can't
mm,
even really, I mean, I must have done it in maths, but it's not where my memory is from.
yeah,
Maybe I should have known that I wanted to be a statistician before because, like, for example, in chemistry, I wasn't the person that ever wanted to do the actual hands-on experiment. Like there was just so much potential for me to be clumsy and do something wrong and not be as accurate as I want to
I
be,
hear
and
you.
and I just knew I'd be plagued with self-doubt of actually getting like everything just so. So give me the plot in your data. Give me the outlining your protocol of the experiment, and then so yeah, for me, I just remember doing everyone's graphs in chemistry because yeah, let's tell everyone what happened in this experiment. The graph's the best way of conveying this information. So yeah, definitely don't remember it so much from maths.
Yep. I mean, that's because I think in physics and chemistry you were learning it in context. You could see the point of it, and in maths, perhaps there wasn't as much point. It's it's a bugbear of mine.
Just from the perspective of maths education and the fact that I'm such a practical person, my huge frustration and the reason that I almost didn't go and study it was because I didn't know why I was learning what I was learning. But I was really lucky having the mathematician at home because he just loves maths so much and
Mm,
actually is a very good communicator and a good educator. And every question I came back was, why am I learning this? Why do
yeah,
I need to know this? And
yeah,
my dad would be like, well, if you're building bridges one day, you need to know this because of this and this. And I would
yeah.
always laugh at him because he'd be saying this to me when I was, pre-teen, and I'd be like, when am I building a bridge? But he had an answer for me, and it brought it back into the real world, and that's what I needed. And I
Mm,
just didn't really, if I'm honest, I didn't really get that enough until I started studying statistics at university,
yeah.
outside of, my dad trying to go, you can do this, you will like it, it's useful. Yeah, okay.
Oh, that's funny. I love hearing you talk about how you just weren't that into it in school because I do because I mean it does make me sad as well. But like so many people feel that way now, and
Mhm.
to think that you can not really be into maths or stats at school and then wind up associate professor of biostatistics at University of Melbourne, head of a research group, and all this stuff, and Eureka Prize nominee and superstar of STEM and all of the things. it's it's um, it's shocking, really, that you
Yeah.
take someone who had obvious capacity and tendency to love this stuff, and you put them through the school system and completely fail to awaken that. Like that.
Absolutely. I loved maths in primary school. Absolutely loved it. And then I just
Mm,
lost it going into high school. I lost my
mm,
confidence with it. And yeah, really, this is where, again, coming back to the mentoring, like people are just so important and having visible role models and backers. Like, if it hadn't been for my dad, and then I was lucky in my final year at high school in Scotland, I had a math teacher who actually was a chemistry graduate who just kept going, why are you not doing this? Like, this, you just really get this, it's really useful to you. But I just didn't know how interesting a job could be with maths, because that was never how it was pitched.
Yeah. Yeah. I hear you. I'm working on it. This has been such a good conversation, and there are so many bits that I'm going to pull out and force people to watch, because they're so on the button of the things that are important. But we are up to the last question, which is my favorite, which is, what excites you about data?
People, always people. Look, I think for me, as I say, coming back to my prior point, the data is one piece, but the excitement of the cool scientists, clinicians, health researchers I'm working with, the ideas they have, the innovations, and the desire to do something to help people is why I do this. And why I want to work with them to get the data they need is because they have this passion and they're just such a joy to be around. And it's all, as I say, about working with them and saying, you've got your area of expertise. I don't know any of this stuff. Like, I'm not a clinician. Like, you need to bring me along with you, and I'll bring you along with me, and we'll work together, and we'll make this the best it possibly can be. And so, yeah, I'm in this job because of the people. And I'm just lucky that I happen to like the maths and the statistics that goes along with it.
I love that. I'm putting that on the wall. Thank you so much. It's been a wonderful conversation. It was worth the wait.
I'm glad. I won't make you wait so long next time.
I'll hold you to that. Thanks for listening to Make Me Data Literate. You can find more episodes at adsy.org/podcast, and you can support our work at givenow.com.au/adsy. Have a great day.